The Constitution of India, Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I hope all are doing good, safe in your house, and I think you would have watched the promo video of Gurukala 2021, which is going to be one of the best memorable event for us, especially for the children who are leaving this year, that is 12th standard. And see, something that is very, very appreciable in our school is at this point of time where the whole world is separated because of COVID, our school has got something different, is doing something different, is just because of our oneness, the unity that we carry among us. And children, I think you all will be excited to watch the youth festival programs, which is going to be a festival for us. And some of you will be also busy in practicing, recording videos for various competitions. Wish you all good luck, children, because it is you who is going to make the program a greater success. That is, you're going to carry this event to the next level. Of course, definitely with all the teachers and principals' support, and expecting the best to come out of it. Wish you all a good luck, children. Eagerly waiting for day after tomorrow, 10 o'clock. So a request is that you share this link to maximum number of people to promote the video, and ask your friends, relations, everyone to watch this online, because it's a platform where they can watch their own children performing great things on stage. Okay, so let us get back into chemistry now. Last class we were watching about enzyme catalysis, and I was telling you what is the role of catalyst. We were also discussing about mechanism of enzyme catalyst, because enzymes, when I say, it's very important because it plays a very vital role in our biological functions. How these enzymes get secreted is just because the food that we eat properly. When you don't eat proper food, when you don't give proper vitamins, nutrients to your body, it may not function properly. So what happens is that you become malnutrition. Right. So for an enzyme catalyst to perform well, definitely role of food is very important, where I mean to say you all should have proper diet, that is regular breakfast at proper time, similarly lunch and also dinner. Okay, so make sure that you follow this very particularly, even if you are not in school, because at home we have our own time leverage. So I don't want you to practice that. Have a healthy food at regular intervals. Okay. Now today we are going to study about colloids. When I say colloids, see, when I mix sand and water, what happens? We know at some point of time the sand will be just mixing with water, and after some time the sand gets settled at the bottom. You can see some waste particles floating on the top. So there is a suspension of particles and there is a solution at the bottom with some sediment settling down. So the region between the suspension and solution, we call it as colloidal particles, colloids. Colloids have got two important things. It's a heterogeneous system. Why do we say heterogeneous? Because two different things are there. One is a dispersed phase, the other one is a dispersion medium. The dispersion medium, just like our adsorption, we say adsorbent and adsorbate. We have a dispersed phase which will be circulating on the top or floating, and we have a dispersion medium, that is a solvent in which you prepare the solution. So the difference between solution and colloid, which is very important. Solution and colloidal solution, they both look the same. The only difference is the particle size. When I say solution, you have very small particles mixed in the solution or in the solvent. But when we say colloidal solution, you have macromolecules. When I say macromolecules, it can be proteins, or these are aggregates of many atoms or ions. So the single macromolecule which has been acting as a dispersed phase in any medium, which we call it as a dispersion medium. Classification of colloids. See, colloids are broadly classified into many types depending on three differences. The first difference is what we are going to see is the depending on the physical state of dispersed phase and dispersion medium. When I say physical state, it should be either solid, liquid or gaseous form. So depending on whether the dispersed phase is in solid or this is in liquid, or both in solid, both in liquid, one liquid, the other one gas, we have various types of colloidal solutions. Examples, you have wiped cream. All the biological fluids that is there in the body also are of colloidal solutions. If I take an example like solids and liquids, if solid is my dispersed phase and liquid is my dispersion medium, you call them as sols, S-O-L-S, sols. And if you take liquid and solid, you call it as a gel, right? You apply gel, hair gel, you apply, right? Liquid and liquid, you call it as emulsion, that is you have the paint, dyes, all these are emulsions. And when water is alone a dispersion medium, that's when you take water as a dispersion medium, you call that as aqua sol, or you also call it as hydrosols. So these are the main classification. The next we will go with the next type of classification. We were seeing about the classification based on the physical state of dispersed phase and dispersion medium. Now here is the classification based on nature of interaction between dispersed phase and dispersion medium. What do you mean by nature of interaction? Interaction means whether they love to make the bond or they love to repel. They don't like in making the interaction. So whether I like to talk to you, I just come towards you when you come to me. If I don't like you, what happens? The moment I see you, I walk away from you. So that is what is the interaction. If I like to interact with you, I come closer. If I don't want to interact with you, I go far away. So nature of interaction between the dispersed phase and dispersion medium, you have major two classification. First one is lyophilic. Lyophilic means liquid loving, which likes the dispersion medium, which likes the solvent, which likes the liquid. Those you call it as lyophilic. Example, like when gum starch, S-T-A-R, when gum starch and all, when they are dissolved in a solvent, immediately they form the sols, colloidal solutions. So those are because they like to mix with water, they love to be interacting with the solvent. This lyophilic sols are called as reversible sols. What do you mean by reversible reaction? The reversible reaction is where the reactants are giving the products and the products can also give back the reactants. Similarly, here they are called as reversible sols because through evaporation, if the dispersion medium can be separated from the dispersed phase, this happens only in the case of lyophilic sols. You can get back your dispersed phase again, and that's why they are so stable. So lyophilic sols are reversible sols and they are stable and they are liquid loving. What is the other category? When something likes something which don't like the solvent. So these are called as lyophobic. So lyophobic means liquid hating, or you can say repelling the liquid. So examples like where some metals and their sulfides, when they are dissolved in any dispersion medium, they cannot form the sols readily. So how you can prepare lyophobic sols? Only through separate methods, not direct mixing of the dispersed phase and the dispersion medium. So, but this once they are formed, they can be readily precipitated. What do you mean by precipitation? They just comes out separated. precipitated on adding electrolytes. When I add a suitable electrolytes, these salts, they get readily precipitated. That's why they are not stable. They are not stable, which they immediately react at all, right? And they are also called as irreversible salts, which means once they form their colloidal salts, you cannot get back into their original phase. That is, once the reaction is over, they do not get back into their reactance phase. So lyophobic salts are called as irreversible salts. So this is liquid loving, this is liquid hating, and here it is reversible, irreversible. These are very stable salts, these are not stable salts. These cannot be coagulated actually, they don't get precipitated here, but here they readily gets precipitated on adding a suitable electrolyte. The next one we are going to study on the based of the types of the particle size. Yes, the next classification is based on the types of particle size of the dispersed phase. So first we classified into three basic classification: multimolecular, macromolecular and associated colloid. When I say multimolecular, multi means more than one. So on dissolution, what happens? Large number of atoms, they form a cluster. They form aggregates of atoms together. They get close together. Such a type of colloid, we call it as multimolecular colloid. Not only one layer, that is when they get separated, they form layers in layers over layer. Those are called as multimolecular. Example, you have gold sol and sulfur sol. Sulfur sols and all S8. Large number of atoms, they will be constituted in that sulfur sol. Next one is macromolecular. Macromolecule means a bigger one. Micro means a smaller one. So when a macromolecule is dissolved in a suitable solvent, it will yield a solution which we colloidal solution, which we call it as macromolecular colloid. That macromolecular colloid is very stable and it resembles a true solution also. It behaves like a real solution. Examples, you have starch and proteins. Even polymers, you can take it as macromolecular colloids. The next one is a very interesting and important concept of colloids, which we call it as associated colloid. In associated colloid, there are some substances, there are some dispersed phase particles which at lower concentration they behave as strong electrolyte, but at very high concentration they exhibit a colloidal behavior. Now why they do behave as colloids is just because they have a tendency to form aggregates. What is aggregate? Just like a cluster. So when that aggregate is formed, it is the formation of a micelle. Right, a micelle formation is there. Now we will learn what is micelle, at what temperature it is formed, and what is the mechanism and its application. Okay, now we are going to see about what is micelle and what is the mechanism of micelle. I told you associated colloids are nothing but at higher concentration they have a colloidal behavior. So what happens? They form a cluster or an aggregate of atoms or aggregate together closely. They do so only at a particular temperature which is called as a Kraft temperature. At one particular temperature, these substances will behave as a associated colloid or they form micelle. Such micelle formed at a particular temperature, we call it as Kraft temperature. And the concentration above that particular concentration, we call it as CMC, critical micelle concentration, which means at that particular concentration only they try to form the micelle. But what happens on dilution? Dilutions means when you add more water, make the whole concentration low, they behave as a normal electrolyte, so they give back their individual ions. Now what is the mechanism? Soap, that is sodium stearate or potassium stearate, anything that you take has got two ends. It has a formula of RCOO minus Na plus, which can be C17H35, any number of carbon and hydrogen atoms, which when dissolved in water will be giving us two different ends, that is one an anion, the other one is a cation. So here we have RCOO minus and Na plus. But what happens here? When this is as an individual ions, we are going to take only our RCOO minus. So in your textbook, this R is represented as CH3, CH2, CH2, long chain of carbon and hydrogen. But to avoid the space constraint, I have written as R, which is my hydrophobic end, which do not like water, which repel with water, and I have my COO minus end, which is hydrophilic, water loving. It likes to stay with water. But what happens with when this is my soap. So when this is mixed with water, the water loving end, that is my anion, gets inside the water, where above the surface of the water is my alkyl group, that is, which is my hydrophobic end. You can see the diagram clearly in your textbook also. But at CMC, at a particular concentration, I told you, they form micelle. So at a particular concentration, after the soap is mixed with water, they do form such a sphere where my anion particle is being attracted into the sphere, where it forms a cluster like this, where all the alkyl end, that is a hydrophobic end, will be facing the center of the sphere, will be dragged inwards, and I have my anion end. So this we call it as an ionic micelle. This mechanism is only used to remove oil and grease from the clothes. That is, when soap is poured on or rubbed on the surface of the grease or oil, the part, hydrophobic part gets attracted to my oil, hydrophilic part gets attracted to my water. So around this oil droplet, what happens? These negative ions, they form a aggregate of micelle, and that is how it gets removed. I will be putting a video for your better understanding, because cleansing of soap, cleansing action of this soap is very important for the micelle formation, and this craft temperature in CMC comes in 1 mark question also. Now we will be learning about preparation of colloids. Now we are going to see preparation of colloids. See, there are 3 preparations, out of which any one can be asked for you in the exam. If they ask you to write any 2 preparation or any one, you can select whichever you want. Or if they ask specifically by Bredick's method or peptization, you should be writing the exact method of preparation. Now chemical methods. To chemical methods, how it is prepared? It is prepared by double decomposition, oxidation, reduction, and or through hydrolysis. That is, you can see 2 examples I have given. The first reaction is through double decomposition, where you are getting the sol respectively, and the second reaction is through hydrolysis by adding water, where you get the ferric hydroxide sol. See, 4 reactions are given. Just learn the reaction, children, because it can come even in 1 mark question. Okay, preparation of colloid. The second one is electrical disintegration or Bredick's arc method. Here we are going to take a beaker or a container, where you are going to insert 2 electrodes of metal in a dispersion medium, and where it is being connected to the external circuit. What happens as the electrodes, that is, as the heat is getting circulated inside, this is a combination of dispersion and condensation medium process, where the dispersed phase, that is the electrodes of the metal, once it is immersed into the dispersion medium, as the heat is getting uplifted, it vaporizes the metal and then condenses back into colloidal particles. That is how the colloidal particles are prepared using Bredick's arc method. The third one is a simple method, which we call it as peptization. In peptization, the main purpose is to convert a precipitate into a colloidal sol. How it is done? You are taking the solution, you are shaking it with the dispersion medium. When you add a small amount of electrolyte, that electrolyte will be acting as a peptizing agent. What does it do? The precipitate, when it is mixed in the dispersion medium, the electrolyte will make the precipitate absorb any of the ion of the electrolyte. When it absorbs the ions, it gives positive and negative ions. And when those negative and positive ions of the electrolyte get split up, they give into individual colloidal particles. So that is how peptization method is used for the preparation of colloidal solutions or particles. See, these are the main important things of colloidal solutions, and we have purification and properties which we'll be seeing in the next class. Okay, so I'll be inserting some videos to make you understand of today's class with more clarity, so that, because seeing is believing. So with that video you will be able to have a clear idea. If you have doubts, please call me children. Okay, so I hope you understood today's class without any confusions, and if you have any doubt, do call as I told you before. Stay home, stay safe, take care, bye.
Classification of colloids. From smoke to fog, ice cream to jelly, and butter to shaving foam, the list of colloids that we encounter in our daily life is long. Each of these entities comprises a mixture of small particles of one substance, suspended and dispersed in another substance. The substances that mix together could be solids, liquids, or gases. Therefore, we can define a colloid as a heterogeneous system composed of two phases, a dispersed phase and a dispersion medium. Colloids are classified into different types based on physical state of their components, nature of interaction between their components, type of particles of the dispersed phase. Let's discuss each criterion in detail. On the basis of the physical state of their components, colloids are classified into 6 types, namely solid sol, sol, aerosol, gel, emulsion, and foam. A solid sol is formed in 2 ways. When the dispersed phase and the dispersion medium both are in the solid state, or when the dispersed phase is in the gaseous state and the dispersion medium is in the solid state. Some examples of solid sols are gemstone and pumice stone. A sol is formed when the dispersed phase is in the solid state and the dispersion medium is in the liquid state. Some examples of sols are paints and starch dispersed in water. An aerosol is formed in 2 ways, when the dispersed phase is in the solid state and the dispersion medium is in the gaseous state, or when the dispersed phase is in the liquid state and the dispersion medium is in the gaseous state. Some examples of aerosols are smoke and clouds. A gel is formed when the dispersed phase is in the liquid state and the dispersion medium is in the solid state. Some examples of gels are butter and cheese. An emulsion is formed when both the dispersed phase and the dispersion medium are in the liquid state. Some examples of emulsions are milk and emulsified oils. Foam is formed when the dispersed phase is in the gaseous state and the dispersion medium is in the liquid state. Some examples of foams are whipped cream and soda water. On the basis of the nature of interaction between their components, that is, the dispersed phase and the dispersion medium, colloids are classified into 2 types, lyophilic and lyophobic. Lyophilic colloids are those in which the particles of the dispersed phase have a great affinity for the dispersion medium. They are formed easily and are reversible in nature. For example, when the components are separated by a simple evaporation process, they can be mixed again to form a sol. They are stable and do not coagulate easily. Gelatin is an example of lyophilic colloids. Lyophobic colloids are those in which particles of the dispersed phase have no affinity for the dispersion medium. They are not formed easily and are unstable. For example, they can be easily coagulated by adding small amounts of electrolytes and by heating or shaking. Once they are coagulated, the components cannot be mixed again to form a sol. Thus, they are irreversible in nature. Silver sol is an example of lyophobic colloids. On the basis of the type of dispersed phase particles, colloids are classified into three types: multimolecular, macromolecular, and associated colloids. On dissolution, the dispersed phase particles of some colloids exist as aggregates of particles with molecular sizes of less than 1 nanometer. Such colloids are called multimolecular colloids. The particles are held together by van der Waals forces. Sol of sulfur molecules is an example of multimolecular colloid. Macromolecular colloids are those in which big-size molecules called macromolecules or polymers form a solution in a solvent in such a way that the size of the macromolecules is still within the colloidal range. According to the type of polymer, natural or artificial, macromolecular colloids can be made of either natural polymers or artificial polymers. Starch and plastic are some examples of macromolecular colloids. Associated colloids are those which behave as a normal electrolyte at low concentrations. At high concentrations, however, they behave as a colloid because of the formation of aggregated particles called micelles. Associated colloids cannot be formed at any temperature or concentration. The temperature above which it is formed is called the Kraft temperature, and the required concentration is known as the critical micelle concentration. An aqueous solution of soap is an example of associated colloid. Classification of samples on the basis of all three criteria. Read the properties of the given samples and answer the question that follows. Select the correct option for each sample and then click Submit. Read the properties of the given samples and answer the question that follows. Select the correct option for each sample and then click Submit. Let's quickly go through what we have learnt about colloids.
Cleansing action of soaps and detergents. A soap molecule is made up of a long hydrocarbon chain that has a carboxylic acid on one end. This carboxylic acid is joined to a sodium ion. The long tail-like hydrocarbon part of a soap molecule is nonpolar and hydrophobic. In other words, while it is not soluble in water, it is soluble in nonpolar compounds such as oil. The short ionic part of the soap is polar and hydrophilic, and it is soluble in water. When an oil-stained cloth is soaked in soapy water, the hydrophobic tails will orient towards the oil stain, meaning the hydrophilic tails will be facing outwards. This ball-like structure with hydrophobic ends towards inside and hydrophilic ends towards outside is called micelle. The hydrophobic ends in the micelle center will dissolve oil and remove the stain. Now that we have looked at the structure of a soap molecule, let's see how soap differs from detergent. Soaps are long-chain carboxylic acids with sodium or potassium salts. Detergents are long-chain carboxylic acids with ammonium or sulfonate salts. Soaps are most effective in soft water and ineffective in hard water. Hard water contains dissolved calcium or magnesium ions. Soap molecules react with Ca2+ or Mg2+ ions and form insoluble compounds that appear as precipitate. Because detergents do not react with calcium or magnesium ions, They are effective even in hot water. Let's see how soap and detergent cleanse when used in hot water. Begin by filling 2 beakers with hot water. In one, add a soap solution and in the other, add some ordinary laundry detergent. Shake the beakers well. After a few seconds, you will see the beaker containing the detergent solution develop a rich foam, and in the beaker with the soap solution, a curd-like layer will form. Summary: the long tail-like hydrocarbon part of soap is hydrophobic and soluble in oil. The short ionic part of the soap is hydrophilic and soluble in water. Soaps are long-chain carboxylic acids with sodium or potassium salts. Detergents are long-chain carboxylic acids with ammonium or sulfonate salts. Soaps form insoluble precipitates in hot water.